1.5 and sort of how that ties back to increasing operational visibility and enabling new business using IT information and systems. So just to get things rolling, there's a couple of places that we've focused in Rocana Ops 1.5. I'm going to talk about them a little bit going forward. So the first thing that we really wanted to focus on in 1.5 was really enabling the ability to see forever within your data. So everything that you collect, eliminating this need to cherry pick through that data, receiving data that is out of date or no longer useful, data that arrives slow, and being able to retain it forever so that you can really go back in time and understand things, how things happen within the data center over time. The second thing we really focused on was understanding the unexpected that's going on within the data center and within systems under management. So plenty of things that we know about and we look for. We really focused on highlighting the unknowns within the system. And that's all about sort of our enhanced anomaly detection and the user experience around it, which allows people to go from an anomaly that we detect within the data all the way back down to the events that precipitated that anomaly. And then finally, I'll talk a little bit about being able to see more. So not limiting yourself to just application logs or just metrics or just network information, but how we've added another kind of data, in this case, wire data, and then Cisco NetFlow integration. Before I get into the details around Rocana Ops 1.5, I wanted to sort of step back for a second and talk about how we see the industry operating today and how we think about it evolving over time. And a lot of this, I think, is going to be old hat and existing news to a lot of folks who are attending today or watching the recording. But the idea here is that we have tons of sources of data, systems that are on-premise, application servers, databases, switches and routers, pretty much everything that makes up traditional IT. We now have this mass amount of applications that are moving to cloud or SaaS providers. We have endpoint devices, everything from mobile devices to point of sale terminals, things that are sort of out in the wild. This, to some extent, gets into the Internet of Things and IoT. And managed services as well. So third-party services that where we may outsource the hosting or management of internal applications. And if you think about it, data information about these systems at the source, theoretically, we have 100% of the data. And I say theoretically because in reality, it's out there, but it's practically, from a practical perspective, it's not actually available for site reliability engineers or DevOps engineers or traditional sysadmins to be able to go and look at. So today we deploy just a myriad of tools that are very purpose-built and specialized for either collecting or analyzing a specific kind of data, whether it's wire data, application logs, what we think of as APM, application performance management data. All of this data is collected by these tools, each of which is built for a very specific purpose. And what winds up happening here, and what we've heard from customers, is that data is getting locked up in silos. We may have distilled application log data, but we have no ability to understand how it relates to wire network data, for instance. We have no real ability with a lot of these systems to understand how business events, abandoned shopping carts, actually correlate with operational events, like an application server going down, for instance. So what winds up happening is the amount of data that we actually have or have access to, at least practically speaking, gets whittled down as data moves from the original source all the way through to the stakeholders of this data. And so what winds up happening is, businesses and a lot of IT teams tend to look to general purpose tools like BI tools like Tableau, Zoom Data, Click, so on and so forth, MicroStrategy, to stitch cohesive views of that information back together. And again, even more fidelity gets lost because these tools may not understand certain kinds of data or may require really rigid structure around the data that otherwise might be difficult to apply structure to. And then finally, they serve that data off to stakeholders. And at that point, the stakeholders really only have slivers of cooked or pre-calculated data. They really don't have a great ability to dig back into what is actually happening on these systems. And what we've seen from customers is that this is actually a huge problem, that this not only reduces visibility into these systems and cuts away the ability to provide quality uptime and as a result, customer service and success to their customers, but it actually creates a barrier to driving top-line business initiatives around eliminating customer churn if you're a telco, or enabling data-oriented products if you're a retailer. It actually creates this separation where you can't actually take advantage of this data for those purposes. So we rethought the notion of visibility and the dimensions of visibility. And what we really wanted to do was create a system that was able to capture a complete view of that data, and not just operational data and not just business data, but how they relate to one another. So the current state of IT monitoring today is really all about these purpose-built systems that are collecting from very specific sources in the data centers, often relatively coarse-grained information, just error messages or warning messages, just stack traces, just performance information, just net flow information or network performance information. It's the retention that data is kept available and online is typically measured in days or weeks, maybe months in very specific cases, but the fidelity of that data tends to be whittled down so that even if you have a couple months or even a year's worth of that data, it tends to be really coarse-grained, removing the ability to really understand what's going on there. And finally, a lot of the state-of-the-art tools today in the ops world are really limited to what we think of as brute force analysis. It's a massive haystack of log events or metric data, and they really just give you a search box and say, have at it. This is really difficult, especially if you don't necessarily know what you're looking for. It's not a good model for looking at the unknowns. So these three dimensions of depth of visibility, the duration, the time element of retention, and the breadth, thinking across, the different sources of data rather than these silos that we think about today. These are the dimensions that we really focused on as part of Rocana Ops. And in 1.5, we've really expanded in a couple of those dimensions, which I'll come back to in just a sec. So when we think about total visibility with Rocana, for us, we think in multiple terabytes of data per day, petabytes of data consolidated across all of these sources. The window of analysis is no longer limited to the last 30 minutes or the last 3 days or the last 7 days. It's years. Show me what happened last Black Friday. Show me what happened leading up to Valentine's Day as a retailer, for instance. And then using advanced analytics and machine learning to surface the unknown issues that people might not actually be able to identify without a little bit of assistance. Again, in thinking about these enormous haystacks of raw data, it's really not practical to ask a human to read line by line, billions of events per day. So again, we've seen this problem of valuable data and information being locked up in cold storage. And our assertion, and in talking to other folks within the industry and our customers, is that if it's not online, you might as well not have it. There's really there's no world in which data that is offline, either on tape or on like frozen storage or something like that in the cloud, is actually useful for real analysis when you're in the midst of a production issue or you're trying to really be able to explore the data without limits. And so I've talked about like Black Friday comparisons as an example. Another one we think that's really interesting is, and I think there's been a bunch of articles about this recently, this notion that people will penetrate a network. Hackers will get into a network and they'll lay dormant for, in certain cases, months before they actually initiate an attack. And by the time they initiate the attack, all of the data about how they got in is actually aged out of operational systems. So even though you may detect there's somebody in the network with SIM tools and things like that are really, really good at detecting those kinds of cases, how they actually got in and the forensic analysis is almost impossible. So Rocana Search, which is one of our marquee features in 1.5, is a new search backend that is a natively parallel query engine that is designed specifically for full fidelity retention of fine-grained event data over time. So from the moment it's captured for as long as you need it. Rocana Search efficiently and linearly scales, so it's a horizontally scalable system and easily handles millions of events per second and up. As a linear scaling system, it is designed to hold constant as the data set increases, or conversely, if you throw more machines at the cluster, query times will actually go down as a result. And finally, we've taken some of the best practices from traditional data warehousing systems. Think systems like Teradata, Oracle Exadata, Vertica, and really pulled a lot of the experience that the engineering and product teams have in the data warehousing space and pulled them into the operational space so that we can manage that data in an efficient way that allows us to minimize downtime and maintenance, allows us to be resilient in the face of failures, and in addition to all of these performance improvements. So just to give you an example, a case study with one of our larger customers or one of our larger deployments, and this happens to be a big box retailer that was deploying Rocana really to create the single source of truth for IT data. And that included security data, compliance data, traditional application performance data, as well as logs and other kinds of metrics. This project specifically was precipitated by a security event where that sort of caused them to stop and think about what kind of visibility they had into the data centers and sort of the services that they were running. So that was sort of the impetus. One of the interesting things here, and just to give you a little bit of visibility as to what the existing solution looked like, these folks were taking in about 3 terabytes a day of new data and retaining somewhere around a month or 2 worth of that data. What they really wanted to be able to do was to be able to take in additional data sources and to be able to retain that data for a longer period of time to better understand trends and things like that. So their initial goals were around, can you get us to 5 terabytes a day? Can you get us, to 10 by the end of the year? With Rocana Search, and specifically with 1.5, they were able to get up to 36 terabytes of data on similar hardware deployment. So we think that this is really exciting. They were able to take a lot of the dollars that they were spending on really fancy hardware and divert those dollars to higher value business projects and business initiatives. One of the interesting things, given that they had all of this new capacity in the system, the ability to take in all this new data, and a system that allowed them to sort of correlate and understand how different kinds of data relate to one another. One of the interesting things that they did was they were able to bring in business transaction data. And in this case, it was a lot of HTTP click data. And the goal here was to really understand how operational systems were impacting their customers and their customers' experience, whether it was on the online store or in brick and mortar locations where they were at like point of sale terminals or self-checkout terminals. So in this instance, and just to give sort of a better example of this, they were really looking at cases around, if somebody encounters an exception on an application server that is the result of some new version of code that's deployed to their online store, they were not able to answer the question of how many users were impacted, or even more specifically, which exact users were impacted, and were those high value customers, or were they people buying, $10, $20 items, or were those shopping carts worth potentially thousands of dollars? So using the combination of user behavior data, or typically what we think of as business data or transactional data, understanding what users were interacting with which pieces of the infrastructure and how those faults on the infrastructure were impacting that customer's experience, and whether that customer came back or didn't come back as a result. This was, this is a huge win for these guys, just the ability to understand the exact monetary value and the priority of these kinds of issues that they were seeing in the data center.
Awesome. Eric, can you talk a little bit about just the hardware requirements?
Yeah, that's a great question. So typical hardware deployment for Rocana is a standard 2U rack mount server with a bunch of spinning disks, so no external SAN storage or anything like that. Typically 12 4 to 8 terabyte drives, anywhere from 128 gigs to 256 gigs of memory. And just to give you sort of an example hardware profile that's super common to see in these deployments is in HP, for instance, it's an HP DL380 Gen 9 box. So that's sort of a typical node size for hardware deployment for Rocana. And then because Rocana is a scale-out system, customers will just deploy tens or even hundreds of those boxes to scale the system out as they want to collect or query or retain more data online. The second major issue that we focused on in 1.5 was this ability to bring visibility to the unknowns within the data center. So a lot of the legacy products that we see leave these huge blind spots where they're looking for the data or the situations or the context that they know about. And that's fantastic. In a lot of cases, they do a great job at that. The problem is in a lot of ways that works great if you know the universe of specific issues that you're looking for, but they don't highlight the things that you don't know about that they weren't designed for. And then the analytics really, again, is just this brute force model where if you're not actually sure where to search, it's really hard to be presented with a search text box as your initial point of investigation. So existing previous versions of Rocana had anomaly detection, but we've really beefed it up and put a lot more meat on the bone here in anomaly detection in 1.5. It's really designed to find abnormal behavior anywhere in the system. So not just on logs, not just on metrics, not just on wire data, all of it. So we believe that this is really interesting because it's reducing these unknowns and it's kind of shining a light on these dark corners of the data center and removing these blind spots. Not just the ability to find that, but the ability to connect it back to the original either trend, deviation in trend or events that actually went into causing that anomaly. This can complement or in certain cases even replace third-party systems. We see a lot of folks actually building internal systems. You know, there's a lot of do-it-yourself in the advanced analytics space. So, you know, and in a lot of cases, IT doesn't have the same resources that the lines of business have. Like marketing teams throw tons of analysts and data scientists at improving product recommendations and things like that. But what we saw was that the IT teams were actually starved for that kind of knowledge and experience. So being able to do that out of the box is really exciting. And then finally, we fully understand the notion that that false positives are a real issue. And you know, we've seen that as well. We wanted to really cut down on the number of false positives here. So we spent a lot of time on trying to improve that as well. Just to give you a quick peek into what this winds up looking like, when people detect these anomalies, and in this case, we're showing a cluster of anomalies over a relatively short period of time, and how we map those anomalies onto physical locations, hosts, services, and even down to the original metrics that where a deviation may have occurred. So we've given folks the ability to think of this as a higher order analytics cube, the ability to view that data from different dimensions and understand how these things are correlated with one another. Once they get an understanding of the severity, where these things are occurring, they can actually drill down and they can see exactly the events within a search view that are going into causing that anomaly, or what is believed to be causing that anomaly. And you can see in this view, we've actually scored each object in the data center at physical locations. You can see here next to this magnifying glass. This acts as kind of like a credit score where higher values actually means the object is more anomalous and more interesting to look into. I think finally, and this is a problem as somebody who's run data centers in the past myself, you know, I used to run into all the time. Operational issues can be extremely hard to diagnose and to debug when you don't have that complete picture. The example that always comes to mind for me is an application server talking to a relational database. So if you have Tomcat applications, for instance, talking to Oracle, and those connections are timing out, that doesn't actually give you a ton of information to go on. So the ability to bring network information into the mix and be able to understand how applications are actually operating on top of that network without having to call a different team, without having to try and hop those boundaries either within the organization or hop those boundaries within the technology and the product. In a lot of cases, it's not uncommon to see site reliability engineers or operations folks with pencil and paper writing down host names and then flipping to another tool and then searching for those host names. We want to break that down. So we want to understand how network data can actually impact the systems that are running on top of the network. And it seems really intuitive as an interesting problem to solve when you think about it from that perspective. So very tactically, we've seen Cisco NetFlow as an interesting source of data to collect. Cisco being like one of the most popular, if not the most popular network device vendor across security products, switches, routers, so on and so forth. So now with NetFlow support, and we support a few different versions of the protocol, we can actually bring in flow information and be able to understand how that impacts applications. This is also fully integrated with Rocana's anomaly detection. So in addition to just sourcing that information and being able to see it along with application data, we're actually able to say, hey, these two parties on the network are talking, and that's fine, that's interesting, but they're talking much more than they ever had before. And we think that that's interesting, or we think that that's abnormal. So we think that this is really exciting, and it includes the ability to drill down to individual events or hosts, locations, services. So finally, just to sort of tie it all back together, some of these new features and enhancements in Rocana Ops 1.5 really cut to the core of the total value prop and sort of where we believe Rocana Ops can drive not just rationalization of tooling or consolidation, which is super exciting in and of itself, but these top-line business initiatives, understanding how operational systems actually impact customers or partners of those running Rocana Ops in their facilities today. So really 1.5 is giving these organizations the ability, the power to see across all three of those dimensions and to see the unexpected with these advanced analytics. If folks have any questions, please feel free to use the Q&A panel, as Michelle pointed out earlier. I'm more than happy to take those questions.
We do have a couple questions, Eric, that came in kind of at the beginning of your session. So the first one is, can you talk a little bit more about how business data is correlated with IT data?
Yeah, so just to jump into the weeds a little bit, typically when a business, and when I say business data, for a lot of people, this is online data. This is HTTP clickstream data. In a lot of cases, that data contains some kind of user identifier, user ID, email address, whatever the case may be, that acts as the key for that portion of the transaction back to the user. And so really what we're doing here is we're understanding this user was issuing this leg of a transaction, a shopping cart checkout, just to give an easy example, on machine 307 in the data center. And that resulted in a stack trace. Now we can understand how that stack trace now ties back to that machine, which in turn ties back to a specific user. And by enriching that data, which Rocana Ops has the ability to do, by enriching that, that event data with demographic information, we can actually say, what's the total lifetime value of user ID, in my case, eSammer. And be able to say like, okay, so here's a person who is trying to check out, who spends a lot of money on gadgets, for instance, on an online store, and they were trying to check out. The size of the shopping cart at that point was $1,000, and it resulted in a stack trace. I can now quantify what is actually happening and sort of how an exception in the newly deployed version of code is actually impacting my high value customers. And in a lot of ways, this gives me the ability to assign real priority to operational issues. So we think that's really exciting. That's just one example.
Great, thank you. To go even a little bit deeper, what analytic and machine learning functions are available to the user and how modifiable are they?
Yeah, so a lot of the exploratory analytics, and I think of those as like simple descriptive statistics. You know, I want to count a bunch of things. I want to take averages, or mean, median, those kinds of things, min, max. I think that's like standard bread and butter for systems like Rocana Ops. We do that information. We do those kinds of operations as well. So if you want to break down your data by different dimensions, and understand not just a specific point in time, but comparatively a specific point in time versus itself a week ago, or a cohort, like in a load balanced application cluster, for instance. I want to see how host 3 compares to everybody else in that host group. Those kinds of analytics are sort of front and foremost. The anomaly detection is really the focus of a lot of the advanced analytics. And again, a lot of that machine learning is applied to uncovering the unknowns. So we use a couple of different techniques to build those models. So they're actually ensemble models under the hood. There's no one specific technique that we use. It depends on the data, but we do actually build a model on our customers' data rather than shipping pre-built models, which allows us to be far more accurate than cooking models and shipping beforehand and shipping them with the product. So all of a lot of the machine learning, a lot of the advanced analytics in the anomaly detection engine is driven off of customer data, which winds up making it far more accurate. I don't know if I fully answered that question, but that's sort of a high level of, some of the places where we apply machine learning and some of the advanced analytics.
So the follow-up question to that was, but you store all of the data so that any tools I currently have can use it. Is that correct?
Yeah, we didn't get really into it today, but Rocana sort of philosophically believes that we don't want to lock your data up. We want you to be able to use this data for other purposes. So we have no proprietary file formats. We have a bunch of open-ended APIs. So if you want, for instance, a real-time stream from our fire hose of all of this event data or metric data, we can give you that in real time. We can also give you access to the stored data set. So if all you really want to do is say, give me this slice of the data so I can pull it into a Tableau or something like that, or even a custom application, we fully support those models as well.
Great, thanks, Eric.
Mm-hmm.
So another question, can you explain or define what you mean by digital transformation?
Sure. This is a really interesting one. And I believe Gartner coined this phrase, but when we talk about digital transformation, what we're really talking about is not thinking about IT as something that simply serves the business. I mean, there's always that aspect to it. But instead thinking about it the other way, asking IT, we have an inventory management problem. What can we do to revolutionize the way that we think about inventory management, or we think about customer service? So rather than building to the old way or the existing way, actually asking IT to be part of the business around how should we build customer service centers and things like that. This is, I think, something that a lot of the newer breed of retailers, for instance, do a fantastic job of. Everybody in the world knows about Amazon, knows about the, some of the interesting abilities they have by taking advantage of IT as a first-class citizen and saying, what should high volume, complex logistics, online retail look like in a world where we have access to past buying behaviors and all of these other kinds of things. So when I think about digital transformation, I think about taking IT from the people who fix my fax machines and keep my Exchange servers running to people who are helping me move product or better serve customers.
Great, thank you so much. Another question, a simple one this time. So when is version 1.5 generally available?
Oh, that's a great question. I'm super happy to report that 1.5 is currently available from Rocana today. So if you're interested in doing like a POC or catching a demo, I've put up some contact information here. Feel free to reach out and we can get that rolling for you, but it's available today.
And one final question in terms of licensing, like do you charge by ingest, by source, by scale? How do we?
Oh yeah, great question. So we think about scalability across two dimensions, technology and financial, economic scalability. And so we really built a pricing model that scaled economically for people. So today our pricing model is based on users of the Rocana application. So not bytes ingest into the system, not nodes in the cluster, not machines under management, but the actual users who are deriving value out of having access to that data. So we believe that this is a much more predictable model for people. Typically, if when I talk to CIOs and I say, how many bytes come into your existing system on Black Friday, most of them will shrug and go, I have no idea. I know what I have in licenses with existing vendors, but I don't know what I'm actually going to want to take in. If I say to them, how many employees do you anticipate having on Black Friday? They can usually give me a pretty concrete number around that.
Another question is Rocana Search open source?
Oh, good question. So Rocana Search today is a proprietary extension that we've written in-house that is really purpose-built for this specific use case. I think it's something, and this is a little bit out of school, but I think we think about what portions of the system really drive value for our customers. And anything that we believe to be commoditized by the open source community, of which more than half of our engineering team actually contributes to, those are the things that we believe should be open source. If something hasn't been commoditized or if it offers our customers a particular advantage, I think that that's a place where we believe that we're differentiated from our competitors. So Rocana Search is currently in that bucket. I think we always reevaluate those decisions over time, but today it's not open source.
All right, and one final question for you, Eric. If you're building machine learning custom per customer, what does the consulting cost?
Oh, great question. So the machines build the models, not consultants. So there's no consulting there involved. The whole point around using things like machine learning and unsupervised methods for building these kinds of models is that it doesn't require a human to come in and really know about the specifics. So it's a general purpose system that requires typically zero customization around model building and things like that. The only time, so the consulting cost, for instance, there is zero. The only place we've seen a lot of people extending the system as part of a deployment is if they have really specialized data sources where they want to get data into the system in a specific way, or integration with downstream systems where they want to serve data in a specific way. And again, there we offer a bunch of APIs. Customers are always free to do that on their own. And typically, we help them as part of a deployment. So we have a team of people that can help out there. And typically we like to think about making the customer successful holistically rather than trying to extract, consulting dollars and things like that from people.
That's great, Eric. So that was the last question. I want to thank you, Eric, for taking this time to share with us. I want to thank everybody for joining us. Again, if you have additional questions or if you want to talk to anybody, you can reach out to Eric directly, or you can reach out to our sales team at sales@rocana.com, or you could even tweet at us. Thank you so much, everybody. Have a great day.